So for today's content, we will talk about gas stoichiometry. So when we say gas stoichiometry, it deals with reaction involving gases where unknown of temperature, pressure, and volume. So in this topic, it is still connected to our last content, which is the gases law. So diba, as we all know, naatay 5 ka type of gases law. And each type of gases law has different formula to use kung unsaang kailangan o unsaang present. Kung volume lang ba o temperature, kung pressure lang ba o volume, or the pressure, temperature, and volume is present. So for this gas stoichiometry, so in order for us to get the gas stoichiometry, the volume ratio is ideally the same as the ideal gas law. So which means that if we're going to solve for the volume, atong gamiton lang daw na formula is the ideal gas law. But if the ratio or the mass ratio atong pangitao naman, we are going to, or a ratio of single reaction has to be calculated from the molecule masses of reactants and products. So which means that kung kuhaon nato ang ratio sa mass, gamito nato ang molecule sa reactants and product. So our gas stoichiometry has two types. So first is mass volume stoichiometry. So when we say mass volume stoichiometry, you are given, or in this situation, given ang mass of one of the component and asked to find the volume of a gaseous component at a stated temperature and pressure, or a standard temperature and pressure, or what we known as STP. So there is a mass volume. If the mass is given, ang atuang pangitaon is the volume using the ideal gas law. So or pwede po siya vice versa. If the volume is given, we're going to solve for the mass. So pwede po baliktaron po nato ang way sa ato ang pag. So mass volume stoichiometry has 3 steps. So first one, convert gas of given to moles by dividing formula mass of the given. So we're going to convert mass to moles, or convert grams to moles. So but before that, before ta mag vary sa or mag-continue sa ato ang step, we must first balance our equation. Kailangan mabalance na nato ang ato ang molecule so that we can proceed to our steps, or maka-proceed na ta og solve sa ato ang mass volume stoichiometry. And the second step, convert moles of given to moles of needed using balance equation. So, ang kani ikaduha na ay similarities with our first steps. Pero atong first step lang is the grams to mole. But our number 2 is mole to mole. So, which means, paano na ito mabalaan kung mauni siya na molecule ang gamiton? So, you need to go back to the question. Mubalik kas pangutana kung unsa ba ang kailangan. So, and our third steps is convert moles of needed to liters of requested using the ideal gas law, or the PV is equals to nRT. And as we all know, R is always constant. So, diba, ang R nato is 0.0821 liter that atmosphere per mole that Kelvin. So that is our the ratio, or the equivalent of R. So these are the 3 steps para ma-solve na to atong mass volume stoichiometry. So from gas to moles, mole to mole, always remember kaning step 2 ang kailangan ninyo bantayan. Kay pag may tag mole to mole, paano nimo mabalaan? So, sa pangutana pa lang daan, unsa di ay ang ginapangita. So, mao to imuhang gamiton nga mole to cancel the molecule nga gigamit nimo sa imuhang first step. Then, after that, pag makuha na nimo na, you can now proceed to solve for your volume. So for our first example of a mass volume stoichiometry, so how many liters of hydrogen gas will be required at a temperature of 300 Kelvin and 3 atmosphere in terms of pressure to consume 56 grams of nitrogen gas? So which means that we are going to determine the liters of hydrogen or our hydrogen gas. And our mass is given from nitrogen gas, which is 56 grams. So first step is we need to convert grams to moles. So this is the first step. But before that, we need to balance the equation first. According to the given, we have two atoms or molecules of nitrogen plus hydrogen gas, which is our reactants, yields to ammonium. So which is NH3. So as you can see, our products results to 3 atoms of hydrogen and our nitrogen is only 1. So since dili siya balance, we need to balance the equation. So if we put 2 here, so 2 times 2 is 2. 2 times 3 is 6. So in order para mabalance ang atong reactants, we just put 3 here. So remember class, always start with number 2. Hay, bisan pag unsa nakadako nga number yung igamit dira, if it is not the least number nga pwede gamiton, then still wrong. Kay dili na magkapareha ang inyong solution. So let's recheck again. So as you can see, it is already balanced. Kay 2 here, is 2 here, then 6, and then 6. So we can now proceed to our steps in order for us to solve the liter of hydrogen gas. So first, convert grams to mole. So convert grams to mole. So our grams here is 56 grams. Multiply to our 1 mole of nitrogen gas over 28 grams of nitrogen gas. So, ma'am, asan yung nakuha ng 28? So, remember our stoichiometry nga topic last quarter, which is to get the molar mass of the molecule or our nitrogen gas. So, cancel out the grams of N2. Cancel out. Then, matira is our mole. So, 56 divided to 28 is equals to, correct, it is 2 mole of nitrogen gas. So, class, always remember or do not forget to write the unit and the substance nga iya nga nabilin. Ay pag malimtanin mo na siya, automatic mali na siya. So 2 moles of nitrogen, and then the second step is convert mole to moles. So convert mole to mole. So since you have our mole of nitrogen gas, we can now proceed to get the mole of our hydrogen gas. So 2 mole of nitrogen gas multiply sa ato ang 3 mole of hydrogen gas over 1 mole of nitrogen gas. Ma'am, nganong ingana man ang way sa second step. Ba, naalala ninyo to kaganina sa ato ang step in order to solve mass volume, convert moles of given to moles of needed. So, i-convert nimong moles na naa sa kailangan nimo na mole sa isa ka molecule. So, atong kailangan, diba, is the liter of hydrogen gas. So, in order for us to proceed for the liter, kailangan muna natin kunin yung mole ng ating hydrogen gas. So, that's the reason why we use 3 mole of hydrogen gas divided to 1 mole of nitrogen gas para ma-cancel nato ato ang nitrogen gas. So, that is the reason. So, 2 times 3, it is 6. Divide 1, so it is still 6. So, 6 moles of hydrogen gas. Then, we can now proceed for our step 3 or step C. So, convert mole to liter. So, i-convert na pod nato ato ang mole to liter using, so in this part, we are going to use na the ideal gas law. So, V is equals to NR over P. So, that is our formula that we are going to use. Wait, let's make it clear. RT over P. So, volume is equals to N, which is the mole of hydrogen gas, times ratio of the ideal gas law, and our temperature over our pressure. So, let's write. So, for our mole to liter, we are going to use the ideal gas law. So, volume is equals to N RT over P. So, N RT. So, we can write 6 mole of H2 over our multiply 0.0821, write all ATM pala to siya. ATM mole over times times 300 Kelvin over our pressure is 3 ATM. So 6 times 0.0821 times 300 divided to 3. So the answer is our answer is, yes, it is 49.26 liter. So this is our final steps. So that is the process in order to solve the following. So here is our second problem. Calculate the mass of oxygen gas at STP, or standard temperature and pressure, required for the complete combustion of 2.64 liter of acetylene at STP. So that is our equation. So acetylene plus oxygen gas yields to our product, which is carbon dioxide and water. So that is our equation. So first, let's balance. So starting here, so 4 carbon, 4 hydrogen. So since here is 4 and this is 1, we're going to put 4. So let's check. So balance na tong carbon. Our hydrogen is not yet balanced. Let's try here 2. So balance na po itong hydrogen. So let's check our oxygen. So here na ay 2 times 1, 2. Here 2 times 2, 8. So we have 10 oxygen. So dali na lang. So since natay 2 diri, we'll just write the 5 para mabalance siya. So balance na here. So since we already balanced our equation, we can now proceed to find or calculate the mass of oxygen gas with the given of acetylene, which is 2.64 liters. So first one is we need to use it is a reverse way para makuha na to ato ang mass. So reverse na to. But first, we're going to get the volume of oxygen. So volume, so step 1, volume of oxygen gas. So equals to 2.64 liter of C2H2 multiply. So kailangan natin ang volume of oxygen. Right here, the 5 liter of oxygen gas over 2 liter of C2H2. So class, kung naglibog mo nganong nagliter na pud na siya, ganina gani ka liter. So actually this one pwede siya mole, molecule, pwede pud siya volume. So that's the reason why liter na pud siya karon. So cancel out. So 2.64 times 5 divided to 2. So it is correct, 6.6 liter O2. So we have now the volume of our oxygen gas. So we can now use our ideal gas to get the mole. PVRT. So that is a way in order for us to get the mole of oxygen gas. Ay hata maka-add to sa mass. So N is equals to pressure. Since STP ta, so we use the standard. So pressure is 1 ATM. We use ATM para manggod ma-cancel out. Our volume is 6.6 liter of O2 So, in gas stoichiometry, ang atong gamiton is ATM and Kelvin. So, our R is 0.0821 liter ATM mole Kelvin. Multiply to our temperature, which is 273 Kelvin. Kaya diba, since it is 0 degrees Celsius man, so 0 plus 273, so it is 273 Kelvin. So, cancel out the ATM, the liter, and the Kelvin. Mabilin is the mole. So, N is equals to, so 1 times 6.66 or 6.6 or, and also multiply po na to una ang 0.821 multiply to 273. So, the result of the 2 or 6.6 divided to 24.41. So, the answer is 0.270 mole of oxygen gas. So, we have now the mole of oxygen. So, we can now solve for the mass of oxygen gas. So, step 3. Dari na lang natin butang. Mass of oxygen gas. So, to cancel out the mole, 0.270 m multiply to 32 grams over 1 mole. So, ma'am, asa nakuha ang 32? So, it is the molar mass of oxygen gas. Since oxygen is 16 times
Our
2, 16
third
plus 16,
type
it
of gas
equals to
stoichiometry is we have the volume-to-volume gas
So,
stoichiometry.
our mass is
So, according to the study, this is the easiest, or according to
0.270
law
times
of combining
32
gas
divide
volumes, that this
So,
is
it's
the
equivalent to
easiest since, or according to the gas volume. So, gases combine at the
64
same
grams
temperature
of
and pressure
oxygen
with whole, or a simple whole
this
number.
is now
So, in this
our
volume-to-volume gas
final
stoichiometry,
answer, and this is the
Avogadro's
way
hypothesis
in order
state
to
that
solve
equal
our
volume of all
mass. So,
gases at
ganina,
the same
our first
temperature
example
and
is we use
pressure. So, which means
mass
we are
in
using
order to
the
solve for the liter.
STP,
So, this
wherein
example
1
naman is
mole
we
of
use
any gas or any
liter
gas
to
at
solve for
STP
the
is
mass.
equivalent to 0 degrees and 1 atm, occupies a volume of 22.4 liter, which means na kapag it is STP or standard temperature and pressure, our volume is always 22.4 liter. And per 1 mole is equivalent to 0 degrees and 1 atm. So which means here our pressure is always equivalent to atm.
So, as what we have discussed kanina, this is a it is the easiest way, or this is the easiest type of stoichiometry, the volume-to-volume gas stoichiometry. wherein you are just going to cancel out lang the liter since per yung gisabi ko kanina na bakit kanya liter yung ginamit ko kasi yung mole dito or molecule pwede siyang maging mole, volume, and molecule. So just like this one ha. Let's try. So let's balance first. So dili balance ang atong oxygen. Right here 2. Then here kay 2. So 4, 2, 4, 2. So balance na siya. So this is the easiest kay liter na daan ang given, tas liter diretsyo ang pagsagot. So for example, this one kaning 2, 1, 2. So pwede siya maging 2 mole. Pwede siya maging 2 volume. Pwede po siya maging 2 molecule. Munang instances kanina class na iba-iba ang gamit nako na unit. So kani siya 1, pwede siya 1 mole, pwede siya 1 volume or liter, and this is 1 molecule. Kani sad pwede maging 1 mole, 1 liter or 2 volume and 2 molecule. So that's the reason why mag-iba-iba ang unit. So since this is the easiest, so sayon lang gid siya class. So solution 40 liter. So 40 liter of hydrogen gas multiply 2 itong ginapangita ay how many liters of water vapor. So it is the water vapor ang kailangan. How many liters of water vapor can be produced for 40 liter of hydrogen consumed in the above chemical? For our second example, how many liters of carbon dioxide are produced when 1.25 liter of CH4, or also known as methane, gas reacts with 2.35 of oxygen gas? Assume that the reaction will only produce carbon dioxide and oxygen gas. So we're going to get the liters when it reacts with CH4 or produce 1.25 of methane and reacts to oxygen, which has 2.35 liters of oxygen gas. So do not forget, always balance the equation. Check first before you balance. So you can see atong oxygen o hydrogen ang nili-balance. Here and here. So 4, then 4, 4. And 4. Balance na siya kay 4, oxygen 1, 2 plus 2, 4. Then 2 times 2, it is also 4. So first, if 1.25 of CH4 are all consumed, the volume of carbon dioxide produced is, so let's solve for the volume of carbon dioxide. CO2. So equals to 1.25 liter of CH4 multiply to 1 liter of CO2 over 1 liter of CH4. Cancel out. Cancel out. So the answer is still 1.25 liter of carbon dioxide. So that is our volume. So very easy. For the second, get the volume. So 2.35 liter of oxygen gas multiply to 1 CO2 or 1 liter over oxygen gas, 2 liter of oxygen gas. So, cancel out. So, 2.35 divided to 2, which is 1.18 liter of oxygen gas. So, that is our volume. So, it's very easy. Your just have to do is to understand the question very, very tight. So, masabtan gid ninyo na class if you understand the question first before you proceed to the steps or how to solve the equation. Interpret the question first before answering. So, that's it for today. Good day and God bless. For our second example, how many liters of carbon dioxide are produced when 1.25 liter of CH4, or also known as methane, gas reacts with 2.35 of oxygen gas? Assume that the reaction will only produce carbon dioxide and oxygen gas. So, we're going to get the liters when it reacts with CH4 or produce 1.25 of methane and reacts to oxygen, which has 2.35 liters of oxygen gas. So, do not forget, always balance the equation. Check first before you balance. So, you can see, atong oxygen o hydrogen ang dili balance. Here and here. So, 4, then 4, 4. And 4. Balance na siya kay 4, oxygen 1, 2 plus 2, 4. Then 2 times 2, it is also 4. So first, if 1.25 of CH4 are all consumed, the volume of carbon dioxide produced is, so let's solve for the volume of carbon dioxide. CO2. So, equals to 1.25 liter of CH4 multiply to 1 liter of CO2 over 1 liter of CH4. Cancel out. Cancel out. So, the answer is still 1.25 liter of carbon dioxide. So, that is our volume. So, very easy. For the second, get the volume. So, 2.35 liter of oxygen gas multiply to 1 CO2 or 1 liter over oxygen gas, 2 liter of oxygen gas. So, cancel out. So, 2.35 divided to 2, which is 1.18 liter of oxygen gas. So, that is our volume. So, it's very easy. Your just have to do is to understand the question very, very tight. So, masabtan gid ninyo na class if you understand the question first before you proceed to the steps or how to solve the equation. Interpret the question first before answering. So, that's it for today. Good day and God bless.